So 3.1. Here's what I'm going to suggest that we do. Okay. This is all review. Okay. So I'm not going to spend too much time talking about it. I will highlight, though, that domain is all your possible x values, and that range is all your possible y values. Okay? Because we'll be finding those later on. Claire, do you need one?
Yeah. Oh, yeah.
I gave you one.
There you go.
Sorry, thank you.
Oh boy.
Save the trees, guys. Yeah, save the trees.
All right, so function, every input has exactly one output. That's something you already know. There's something we call the vertical line test. Okay, so these options here are 4 different ways that you can decide whether or not some sort of relationship that you have is actually a function or not. Okay, so let's start with example 1. If this column represents all the inputs, okay, it doesn't have to be numbers, it can be objects or letters, okay? Every input has to have how many outputs? Exactly 1, okay, in order for it to be a function. So Adam has 1 output, chocolate. Amy has how many outputs? So right there, we're going to say this is not a function because you have to have you can only have 1 output for each input. Does that make sense? Okay. So if you see a table like this and you see 2 arrows coming out of the input, right away that's not going to be a function. Okay. Now let's look at the second one. Is this table going to be representing a function?
Yeah.
Yes. Okay. Who said no? Heard like 1 no and a bunch of yeses. No one wants to say it was them, huh?
Nope.
If you're thinking, well, what about vanilla and strawberry? It doesn't necessarily mean that every y value has to be used. Okay. It just means that every x has to go to 1 spot. Could it go to the same spot? Yes. Okay. In fact, if all 5 of these said chocolate was their favorite ice cream flavor, it still would be a function. Does that make sense? Any questions on that? Okay. So let's start with the easier one in example 2. Here we just have 2 equations. Okay. This one already has y alone. And so if you think about it, when you plug in an x value, so if you plug in like 5, for instance, how many y values do you get from that?
1.
You just get 1, right? In fact, no matter what you plug in, if you plug in 0, you get 1 answer for that, right? If you plug in 100, you get whatever that equals, just that 1 answer. Everybody with me here? Okay? So this is, when you plug in an x value, you get 1 y value. That's the key. So this is a function. Okay. On the other hand, a good way to figure out if this is going to work, first let's get y alone. Okay, and this is where people make a mistake sometimes. So think back to algebra now. How do you undo a square? You square root both sides. And do you guys remember that when you take the square root of both sides of an equation, what happens on this side? Do you just get root 2x plus 8? What if I said this? What's y here?
2.
Just 2?
Oh, negative 2.
Plus or minus 2. Both of those, when squared, equal 4, right? Does this sound familiar that when you square root both sides of an equation, you get plus or minus the root? Does that make sense? Okay. So in this case, if you plug in an x value, how many y values are you most likely going to get here?
2.
2. Does everybody see that? So is this going to be a function?
No.
Exactly. You get 2 y values. So this is not a function. Okay? So we're working through all the different modes that you need to be able to recognize. Yes, this is a function. No, this relationship does not represent a function. Okay? First we did a table. Now we looked at a couple of different equations. This one works. That's going to be a function. This one, however, we saw that it's not going to be. Okay? Now, we'll talk about this in a minute, but we might as well review vertical line test. Okay? If you know what these pictures look like, okay, right before we left for break, we talked about parabolas and all these different kinds of graphs, right? Do you guys remember what this minus 2 does to the picture?
Right.
That would be if the minus 2 was inside of the square. But you're on the right track.
Down.
It's just going to move it down 2. So this picture is just a regular parabola just shifted down. Does that make sense? And remember that the vertical line test tells me that if I take a vertical line and slide it across, that it should always intersect the graph how many times? Once. So this visually you can see it's a function. Does that make sense? This one over here, if you graph it, actually ends up looking something like this. It's a sideways parabola. Whenever y is squared as opposed to x, you get a sideways parabola. And now it fails the vertical line test there. Okay? All right. Last example about functions and if they are a function or not a function. Why don't you guys take a minute? Look at each one, make a decision. Yes, it's a function. No, it's not a function. And then explain why it is or why it is not. All right, Francisco, what do you think? 2A.
It is
Why?
because I did the test and the vertical line.
It passes the vertical line test. Okay. I buy it. Do you guys buy it?
Yeah.
I would have argued that each x has
Oh,
1y as opposed to like graphing these, but either way. Okay, or if you're going to use Francisco's explanation, just don't say because I did the test. Say passes vertical line test or, use the definition. What about B?
It's not.
It is not. Why?
There's 2x values that would be
So which x,
4.
10 has how many y values?
Two.
2 different y values. Okay. Does that make sense? Okay, I'm going to quickly do example 4, and then you guys are going to do example 5 on your own. So this is just function notation, right? All it means is to do what with this 1 here? You just plug it into the x values. Okay. Hopefully this looks familiar. You should have seen this somewhere along the road. So this is just going to be, if I use this rule, the opposite of 1 plus 4. In other words, negative 1 plus 4 is 3. Okay. Now here's where students start to get a little confused, because with numbers usually they understand you just stick the number in there and figure it out. It works the same no matter what is in the parentheses. So in this case, f of t is going to be the opposite of what? T, whatever that might be, plus 4. And then that's all you do with it, because you don't know what t is, so you just leave it as an equation. Okay? This one, we're replacing x with negative x. So you still have the initial negative, but now you're plugging in negative x into it. And so your final answer is just positive x plus 4. Is that making sense to everybody? Okay. 2x minus 3 is now my new input. So you follow the rule. Do the opposite of your input, which is now 2x minus 3 plus 4. And now we're going to use some algebra and simplify that a little bit. What can I do with this negative? Okay, so this is going to be negative 2x plus 3 plus 4. Combine like terms, negative 2x plus 7. Make sense? Okay, try 5 on your own. In fact, I'll get my answers ready. You guys try it first, though. Yes. Do you guys hear his question? Say that louder, because it's good.
Do you plug the gene for both x's?
You mean the 2 or the...
Yeah.
So do you plug the input into both of the x's? Answer is yes. Okay, so all the x's get replaced with whatever is in here. All right. Brian looks like he's ready to impart some answers. What'd you get for A?
1 over 9.
Okay, good. B, Jackie, what'd you get? Negative 6 over 11. Yes. And C, Philip. It's actually the same
Oh,
thing.
yeah.
So actually, I'll clarify that in a minute. What did we get for C?
3.
Okay. So initially, you get 6 over negative 11. So you could leave your answer like that. Although typically what's going to happen is most people would just write the negative in front of the number. It doesn't matter whether the top is negative or the bottom's negative. It's just the whole number is negative. Does that make sense? Okay. Example 4. Let's work through that one real quick. Okay. So here they're just asking us to take this equation, get y alone, and then now you're going to use f of x in place of y. Okay. So how do I get y alone here? What do I do first?
Subtract the x.
Subtract x. Good. So we get 3y is going to equal,
Negative x plus 10.
sure. Okay, and what's the last step? Divide by 3. So this is totally fine. They're not asking for a certain format or anything like that, so you can leave it like that. Some people might be used to writing kind of like what you did with slope-intercept form back in the day, writing this as negative 1/3 x plus 10 over 3. Both of those are totally fine. Okay, whatever floats your boat. And so now they're saying let y equal f of x. So this is my rule over here. We're just going to use negative x plus 10 over 3. That's my f of x rule. Okay. Now it's just plugging in 13. Okay, so these problems aren't too hard. It's just a matter of understanding what the directions want you to do, right? And then following through and simplifying and making sure you don't make any little freshman year algebra mistakes. Okay. Let's see, what should this be? Negative 3 plus 10. Negative 3 divided by 3. I'm getting negative 1. Okay. Does that make sense? Okay, so we've done a couple of things. We've reviewed or learned, for some of us, how to determine if something represents a function. We've played around with function notation a little bit and understood how to plug stuff in and simplify it. Okay, next, we're going to talk about domain and range. Okay? And look, here's what I'm going to emphasize. This table's pretty nice. Okay? As far as what to look for domain and range. Okay? What I always like to focus on when we're finding domain or range, especially with domain, think about what doesn't work. Okay? So, for example, before we even review any of this, let's say I have this function here. Okay, and let's just talk about domain. Okay? In all the years that you've studied math, elementary, middle, and high school, you learned about adding, subtracting, multiplying, and dividing numbers, right? You've probably learned along the way that there are certain things you can't do, though. Like, what can you never divide by? Sound familiar? Okay, so that's one thing that you're not allowed to do, right? Also, you cannot square root what? Negative numbers, right? So, those are right here. These are the only two cases where the domain is anything or is something different than all real numbers. Okay? So if I look at this example, I see x squared plus 2. Okay, so there's two ways that you can think about this. One way is I don't see a fraction and I don't see a square root, so my domain is going to be all real numbers. Because those are the only two things that you have to kind of pay attention to for domain. Okay? The other way to do this would be to think, okay, if I plug something in, the first thing you do is square whatever that number is, right? And there's no rules against squaring numbers. You can square any number, and then you can add 2 to any number. Okay, but that's a little bit more complicated than just remembering this. Does that make sense? Okay, so if you just remember these two exceptions, Square roots, we have issues with domain. And fractions, we have issues with domain. Then you should be okay. Okay? We'll talk about range a little bit more later. Let's worry about domain first. Okay? So let's work through these examples, and then I think we'll call it a day. All right, so hopefully what I explained up here made sense. Looking at this function, is this one of the two cases that we have to be worried about? What are the two cases again? Square roots or fractions. So do we have to worry about anything here? So the domain is all real numbers. Okay? Hopefully the interval notation is making sense. We did that a little bit before break 2, so if you forgot, look through your notes. All right, now we have what here? Square root. So no, we can't just say all real numbers because that's not gonna be it. So now we got to think, well, what do I know about square rooting things? What I'm remembering is that this number in here, whatever's on the inside, has to be higher or equal to 0. It can't be negative. That's the only thing we have to worry about, right? So that's actually, that's exactly what's in the table up there. You're just going to take whatever is in the radical, you're going to make it greater or equal to 0, and then you're going to solve this like you normally solve the inequality. Okay, so what 2 steps do you have to do to get x alone here? Subtract 14 and then divide by -2. So what happens to this symbol here? And now we get, what is that, 7. So x is less than or equal to 7. Okay? This would be like on an exam. If I'm grading your test, you guys, unless it tells you how to write your domain, you could write interval notation. You can write me an essay. I don't care as long as you tell me what the domain is. Okay? This is a totally valid way of saying what the domain is. But you should also know that this is the same as the interval with a bracket from 7 to, I screwed up. Less than. So we should go -infinity to +7.
Okay, so the domain is -infinity
To +7. Because think about how you would graph this if it doesn't make sense looking at it. Remember the graph for that is a number line, closed circle on 7. Where do you shade? You shade left. And so now if you look at the number line, this kind of matches up when you look at the interval. Does that make sense?
Yeah.
Okay.
I just
Ooh.
thought the x less than or equal to 7 is the domain.
Both of them are
Oh,
mean the same thing. That's what I was trying to say. All right. Next problem. What do we see here that we have to worry about? The fraction. In particular, we're never allowed to divide by 0. Okay? So what we're going to do is take the denominator, x cubed minus 4x, and we're going to say that that cannot equal 0. Okay? And now you just solve for x to figure out what values don't work. Because this doesn't tell me what x values don't work. That tells me that this equation doesn't work. We got to figure out what x values don't work. Okay? Do you guys remember how to do GCFs?
Isn't it multiply the outsides to add up to the
That would be if it were like a trinomial, like x. Yes. Greatest common factor. Can we take anything out? Take out an x. What's left? X squared minus 4. And now we got to keep factoring. How do we factor x squared minus 4?
x plus 2 and x minus 2.
Good. And now here's where, the algebra comes back. There are 3 x values that make this equal to 0. Do you guys remember the 0 product property where you take every single one of them and make it equal to 0 and then solve? That sound familiar? So take x. X cannot equal 0. If I set this equal to 0, x plus 2 cannot equal 0. If I take the third one, x minus 2, that one also cannot equal 0. So my domain, I already have one of them. 0 doesn't work. What else doesn't work here? How do you get x alone in this one?
Subtract.
So x cannot equal negative 2, and what's the third one? Positive 2. So here my domain is everything except these three numbers. Okay? All right, we'll pick up where we left off tomorrow. As far as homework